Hello dear students, welcome back to the another episode of classification of elements and periodicity in properties chapter. In the previous class we studied ionization enthalpy property. Today we'll study one more periodic property, that is electron gain enthalpy, or we call it as electron gain energy. So it is also called as electron affinity. So all the three words are meanings are same: electron gain enthalpy. First we'll see what is meant by electron gain enthalpy. Suppose when an electron is added to a neutral gaseous atom, such that neutral gaseous atom converted into a negative ion, converted into an anion. Whatever the energy change, enthalpy change occurs during that process is called as electron gain enthalpy. In simple terms, say we have an atom, a neutral atom which is in gaseous state. Suppose if an electron is added, if this electron is added to this neutral gaseous atom, that neutral atom changes into a negative ion. Okay, so when an atom is added to a neutral atom, that gets converted into a negative ion. So during this process, whatever the enthalpy change, energy change takes place, that energy change is called as what? Electron gain enthalpy. ಓಕೆ, ಸಿಂಪಲ್ ಆಗಿ ಹೇಳಬೇಕಾದ್ರೆ ಯಾವುದೇ ಒಂದು ನ್ಯೂಟ್ರಲ್ ಗೇಸಿಯಸ್ ಸ್ಟೇಟಲ್ಲಿರೋ ಅಟಮ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ನ ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಅಟಮ್ ನೆಗೆಟಿವ್ ಅಯಾನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತದೆ. ಆ ಪ್ರೊಸೆಸ್ದಲ್ಲಿ ಏನು ಎನರ್ಜಿ ಚೇಂಜ್ ಆಗ್ತದಲ್ಲ, ದಟ್ ಎನರ್ಜಿ ಮೇ ಬಿ ಆ್ಯಡೆಡ್ ಟು ದ process system or energy may be liberated from the system. That change in energy is called as what? Electron gain enthalpy. Okay, so we'll take an example. We have a chlorine atom, a neutral atom which is in a gaseous state. Suppose if an electron is added to this chlorine neutral atom, so it releases energy. It releases a certain amount of energy. That energy is called as electron gain enthalpy, and the chlorine atom gets converted into a chloride ion. Look here, Cl converted into Cl minus, a chloride ion, a negative ion when an electron is added. So during this process, during this conversion, certain amount of energy is released. Okay, here I have said enthalpy change. Change means energy may be added, energy may be released. That depends upon the element. Here in this example, energy is released. That energy is called as what? Electron gain enthalpy. So for this conversion, for the conversion of Cl into Cl minus, the electron gain enthalpy value is 348.5 kilojoules per mole of energy. Look at the sign. So illenide energy value in terms of a negative. So negative dalli bardre artha eno? Energy is released. The process is exothermic. Okay, so 348.5 kilojoules per mole of energy is released. So when an electron is added to chlorine atom, therefore for this conversion, EGE means electron gain enthalpy is minus 348.5 kJ per mole, kilojoules per mole. Okay, so look at here one more example. To the fluorine atom, a neutral gaseous atom, if an electron is added, it gets converted into F minus, fluoride ion. Okay, say this is fluorine atom with atomic number 9, nuclear charge +9, and it has got a 9 electron. If an electron is added, so it gets converted into fluoride ion which is having 10 electron, but the protons will remain same, 9 only. Okay, so during this conversion, energy is released. That is called electron gain enthalpy, which is measured in terms of the unit kilojoules per mole. Clear? What's meant by electron gain enthalpy? Okay, fine. So depending upon the element, as I said you earlier, depending upon the element, the process of adding an electron to the atom can be either endothermic or exothermic. Andre So this conversion, no, addition of electron to the atom. So this process may release the energy exothermic andre from the reaction system andre from the process energy may be released to the surrounding. ಅದಕ್ಕೆ ಅಂತಾರೆ exothermic reaction, or it may be endothermic andre energy is required for the conversion. Okay, so energy release ಆಗ್ಬೋದು, energy absorb ಆಗ್ಬೋದು. That all depends upon what? Depends upon the element. Okay, so for many elements energy is released andre most of the elements of the periodic table will release energy whenever an electron is added to the atom, and the electron gain enthalpy will be definitely negative. So exothermic andraga the value will be negative. Okay, so next slide I'll show you some values of electron gain enthalpy of different elements. There you will come to know which all elements will release energy and which all elements will absorb energy during this conversion. Clear what's meant by electron gain enthalpy? Artha aita? Okay. Now we'll see how this electron gain enthalpy varies in the periodic table, how it varies along the period of the periodic table, as well as how it varies down the group of the periodic table. Okay, so variation of a electron gain enthalpy, periodic trends of electron gain enthalpy. First one, variation in a period. Look at this table. Say this is first period, only hydrogen and helium, 2 atoms are mentioned in this table. Look at the second row, lithium minus 60 electron gain enthalpy, oxygen also belongs to second period. Okay, lithium naduve ಕೆಲವೊಂದಿಷ್ಟು element ತಗೊಂಡಿಲ್ಲ ಈ table ದಲ್ಲಿ. This table is mentioned in your book. So oxygen, which is also belong to the second period, minus 141 kg per mole, fluorine minus 328, neon plus 116. Look here. So most of the elements, so these all elements have negative electron gain enthalpy. You take a first group, alkali metals, or even you take a group number 16, group number 17. So some of the groups have been mentioned in this table. They all are having negative electron gain enthalpy. Means what? Energy is released whenever an electron is added to neutral gaseous atom. Energy release ಆಗ್ತದೆ. ಆದರೆ ಪಾಸಿಟಿವ್ ಎಲ್ಲಿದೆ ನೋಡಿ, group 0. Actually it's a group number 18, noble gases, inert gases, helium, neon, argon, krypton, and so on. So they have positive electron gain enthalpy value plus 48. Can you see here? Plus 116, plus 96, plus 96, and so on. Andre whenever an atom is added to noble gas, the energy is not released. Instead, energy is absorbed during that conversion. Andre noble gases will not easily accept an electron. They will not easily accept an electron. Therefore, their electron gain enthalpy values are positive. Okay, they are, because they are all stable elements. No, they are inert gases. They are having a stable electronic configuration. We have studied in a classification of elements. So since they are having a stable octet state, they do not accept electrons easily. Therefore, they have positive electron gain enthalpy. So except these noble gases, rest all elements electron gain enthalpy is negative. Okay, now we'll see how it varies in a period. In this table, say this will take this second period, lithium. Some of the elements have been mentioned, not all. Lithium minus 60. Then oxygen also belongs to the second period, minus 141, minus 328. What happens here? Leave these noble gases. Okay, on a bit, they are exceptional cases. Minus 60 to minus 141, minus 141 to minus 328. What happens to the electron gain enthalpy? So it becomes more and more negative. Yes or no? Minus 60 to minus 141, more negative. Minus 141 to minus 328. So more and more negative. More and more negative value means what? More and more energy is released. Okay, andre electron gain enthalpy increases anta helbodu. Energy released will be increased, or we call it as a along the period electron gain enthalpy becomes more and more negative value. Why? Why? We'll see the reasons now. Why it becomes more and more negative. When you move along the period of the periodic table from left to right, okay, the effective nuclear charge increases definitely. So from lithium to beryllium, beryllium to boron, then to nitrogen, oxygen, fluorine, what happens to the atomic number? Increases. Nuclear charge increases from left to right. So, and as the nuclear charge increases, we know that atomic radius decreases, and it will be easier to add an electron to the smaller atom, since the added electron is closer to the positively charged nucleus. Okay, so let me explain this reason by taking one diagram. Look here. Assume, imagine these elements are the elements of this one second period anta ankodripa. Okay, now along the period, what happens to the atomic radius? Look here, the size of the atom is larger. Come here, next element bit smaller, next bandre innu smaller andre along the period atomic radius decreases. This concept we studied in previous class. Now my question is, addition of an electron to this atom is easier, or addition of an electron to this last atom is easier? Where it is easier? Definitely in the last atom it is easier, because the added electron will be near to the nucleus. Atom is small. The distance between positively charged nucleus and the added negatively charged electron will be less. So yavaga ಇಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಆಗ್ತದೆ ಪಾಸಿಟಿವ್ ಮತ್ತು ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ನಡುವೆ, ಡಿಸ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಆದಾಗ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ ಮೋರ್. ಸೊ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಯಾನ್ ಬಿ ಈಸಿಲಿ ಆಡೆಡ್ ಇನ್ ದಿಸ್ ಸ್ಮಾಲರ್ ಅಟಮ್ compared to here. So here what happens? The size is bigger, the radius is large, so added electron is far away from the nucleus. ಈ ಪಾಸಿಟಿವ್ ನ್ಯೂಕ್ಲಿಯಸ್ ದಿಂದ ಈ ಆಡೆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ದೂರ ಇರ್ತದೆ. ಯಾವಾಗ ದೂರ ಇರ್ತದೆ, ಎಡಿಷನ್ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತದೆ. ವೆನ್ ದ addition is difficult here, it releases less energy, -60. When the addition will be easier due to the smaller size, due to the small atomic radius, when the addition is easy, it releases more energy. Therefore, look here, fluorine -328. Clear? So, conclusion madudadre, along the period, atomic radius decreases. Along the period, effective nuclear charge increases. ಇವೆಲ್ಲ ನಾವು ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸಲ್ಲಿ ಕಲ್ತಿದ್ದು. Therefore, when the atom size is smaller, the addition of electron is easy, it releases more energy. Therefore, along the period, electron gain enthalpy becomes more and more negative. Look at this table. Take third period, sodium -53, sulfur -200 becomes more negative, chlorine -349 ಅಂದರೆ ಇನ್ನೂ ಜಾಸ್ತಿ ಆಯಿತು, ಹೌದಾ? ಸೊ ಅಲಾಂಗ್ ದ ಪೀರಿಯಡ್ ಎಡಿಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಈಸಿಯರ್, ಮೋರ್ ಎನರ್ಜಿ ಇಸ್ ರಿಲೀಸ್ಡ್. ಫೈನ್. ಓಕೆ, one more concept, how this electron gain enthalpy varies in a group of the periodic table. Okay, again look at this table. This is the first group. Group number 1, hydrogen, lithium, sodium, potassium, rubidium and cesium. Group number 1. Group 1 ದಲ್ಲಿ ಏನಾಗ್ತಾ ಹೋಗಿದೆ ನೋಡಿ, ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ -73 to -60 decreases, may or it becomes less negative. -60 to -53 less negative, -48, -47, -46. That means when you move down the group of the periodic table, electron gain enthalpy ಏನಾಗ್ತಾ ಹೋಗಿದೆ? Increases or decreases? Decreases. It becomes less negative. Along the period, along the group, electron gain enthalpy becomes less negative. Andre less and less energy is released. We'll see the reason for this. Because the size of the atom increases. You know, when you move down, atomic radius increases, size increases, and the added electron is farther from the nucleus. It will be far away from the nucleus. Nucleus dinda ದೂರ ಇರ್ತದೆ. ಎಕ್ಸಾಂಪಲ್ ನೋಡೋಣ. Okay, say here, here, this is the first period, first group ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ, ಅಸ್ಯೂಮ್ ಮಾಡೋಣ. ಸೊ ಇನ್ ಡೌನ್ ದ ಗ್ರೂಪ್ ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಏನಾಗ್ತಾ ಹೋಗಿದೆ, ಇನ್ಕ್ರೀಸಸ್, ಬಿಕಾಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ being added to the new shell, number of shells increases. So as you go down, size increases. Now tell me, addition of electron to the first atom is easier or to the last atom is easier? Definitely it will be easier in a smaller atom. So when it is easier, more energy is released. When here it is difficult, look here, when you move down, less and less energy is released. So reason for this variation is again depends upon what? Atomic radius. First property we discussed, no, atomic radius. Okay, ಹಾಗಾದ್ರೆ summary ಹೇಳೋದಾದ್ರೆ, when you move down the group of the periodic table, atomic radius increases, size increases, the addition of electron becomes more and more difficult. Okay, the added electron will be far away from the nucleus. Okay, so ಇಲ್ಲಿ the distance ಜಾಸ್ತಿ ಆದಾಗ, this is the can you see this blue colored one, it's a nucleus. This red colored is the added electron. When the distance between the positively charged nucleus, negatively charged added electron is more, so the addition becomes a bit difficult, releases lesser energy. Whereas here the distance is small, added electron is close to the nucleus, addition is easy, more energy is released. So along the period, electron gain enthalpy becomes more and more negative, more and more energy is released, whereas down the group it becomes less negative or less and less energy is released. Whereas exceptional cases are noble gases, wherein energy is not released, instead energy is absorbed whenever an electron is added to the neutral gaseous atom. Okay, so this is the small concept of today's class. We discussed what's meant by electron gain, enthalpy, and how it varies along the period and down the group of the periodic table. Okay, so I thank you very much. If you like my video, subscribe to my YouTube channel and share this video to your friends. Thank you very much. So we'll meet you in the next class, so wherein we'll discuss the last periodic property of this chapter, that is electronegativity. Thank you very much.